Hello and welcome to space here from a mountaintop observatory in southern Germany. We're here to talk about the weather and how scientists are using brand new satellite technologies as well as the kind of systems you see around us here in order to solve some of the greatest mysteries of our climate. To better understand our atmosphere, we need to gather data, and that's just what this team are doing here at the Hohenpeißenberg weather station in Bavaria. For the past 50 years, they've been launching weather balloons here, producing measurements which are combined with satellite data to verify weather and climate models.
We measure the temperature profile, the humidity profile, the wind profile, and in addition we measure the ozone profile. And we're interested in it now, because we want to see how the ozone layer recovers.
Earth's high-altitude ozone layer was damaged by man-made pollution from CFC gases in the 20th century. This balloon will offer a precise local measurement of the ozone above southern Germany.
Also, now she goes up to space. Well, first we'll go through the first layers, then we'll reach the free atmosphere here, which is not contaminated by the stuff close to the ground. It'll get colder, 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 until we start reaching the stratosphere, where most of the ozone sits and where the temperature gets warmer again. That'll happen at about 10 kilometers today.
Even more data on pollution and ozone will come from this new ESA satellite, Sentinel-5P, launched on October the 13th. It's part of the European Commission's Copernicus Earth Observation Programme and will measure pollution and ozone levels in unprecedented detail. It should offer vital information on where harmful emissions come from and where they go.
You have one satellite instrument measuring the complete globe. It means that you have one calibrated instrument measuring everywhere. It means that you can compare the pollution levels in Europe directly with those in China and the United States.
Sentinel-5P's instrument Tropomi, developed in the Netherlands, could also be the instrument to clear up the mystery of whether our planet's ozone layer is on the road to recovery after harmful CFCs were banned in 1989.
Currently we still have every year an ozone hole. And this ozone hole is there between September and October over the South Pole. Globally speaking, we still have degrees of ozone compared to the 1960s, 70s. We expect that the ozone layer will improve, and I think it will be maybe this year, maybe next year, maybe Tropomi will be the instrument to really prove it, that indeed the ozone layer is recovering.
There's a great deal that remains mysterious about Earth's atmosphere. In the coming years, new European satellites will seek answers to how pollution contributes to cloud formation and the role of methane in climate change. Then there's the question of the wind. It's a fundamental parameter, yet we really don't know enough about it on a global level. ESA will try to address that in 2018 with a satellite called Aeolus, which will measure Earth's winds from space for the very first time.
At the moment we are limited that we don't have many wind measurements everywhere. This is actually one of the biggest challenges in forecasting today, is to get the wind right. And that's where the satellite measurements come in, and this mission, which will provide wind measurements from the ground, far up in the atmosphere, all over the globe, to help the modelers do better.
Developing a device to measure wind from space has been a long and complex process. The engineers at the German Aerospace Center in Oberpfaffenhofen have been flying tests in their aircraft to calibrate their LiDAR instrument.
DLR has developed an airborne prototype of the instrument on the satellite, and we are flying this airborne prototype on this aircraft and testing the instrument and validating the instrument. And it's very exciting research, because we're already getting before launch the same data as it would have been from the satellite, and so we can test our algorithms on this data, and we are getting hand-on experience, which is very important.
Once launched, the Aeolus satellite will measure winds at 10 to 30,000 meters above our heads, zones where there are virtually no readings at present. The data will be used to improve forecasts right away.
You can measure with EOLUS the wind profile globally. You can measure it in the tropics where we don't have any wind observations today. You can measure it over the oceans. We don't have any radiosonde launches or balloon launches over the oceans. And wide part of the Earth are oceans. And you can measure it in Antarctica. You can measure it in the Arctic where all the climate change is going on.
Back at the observatory and the weather balloon readings are being recorded. We're now gathering much more and better quality data than ever before, essential information to solve the many mysteries of Earth's climates.
We know climate is changing. What we do not know in detail is what is meaning for different regions. So, are we going to get warmer summers here? Probably. Will we get more rain? We already don't know that. How is it going to change in different parts of the atmosphere? What will be the effects of that? But what we're trying to do is provide the solid data together with the satellites that will tell us how the atmosphere is changing.
And now to the latest episode in our mini-series Legends of Space, looking back at some of the greatest moments in spaceflight. This month we've chosen to feature the Voyager mission, twin probes which set off from Earth 40 years ago and are now deeper into space than any man-made object has ever gone before.
Somebody in the US had this great idea that if you select the launch date properly, that you can, with one spacecraft, you can visit all the planets. So they launched 77, then they went to Jupiter, Saturn, Uranus, Neptune.
The Voyager missions are a great example of how big space is. The fact that we sent them out in the 70s and there's still the ongoing debate as to whether they've left the solar system or not. It's that old adage, space is big, and the Voyager missions are demonstrating that because they haven't even got out of our backyard yet.
The worlds were amazing. I mean, Saturn is super beautiful. The storm systems and the atmosphere of Jupiter are amazing. The moons, Io with all its volcanism, and Europa white with all this water. So, just visually, it looked like a collection of jewels.
Well, that's all for now. It's time to say goodbye from us here in Bavaria. Next month, we'll be back with a feature looking at some of the latest technologies to keep space clean from debris. In the meantime, keep up to date with other news from the universe on our space blog on Euronews.com.